Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're super excited to bring to you some activities that you can use with your students to get them ready for Pi Day. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough to teach, tough to learn concepts accessible to all my students. Tonight, we're lucky to be joined by our two panelists, Veronica Carlson and Kim Thomas. For 35 years, Veronica has taught mathematics, where she most recently taught college algebra. Veronica is also an adjunct math instructor at Glendale Community College. She's presented at many national, state, and local conferences and enjoys working with teachers, helping them to integrate TI technology into their classrooms to help students have a greater understanding of mathematics. Veronica, we're excited to have you here tonight.
Good evening. I'm excited to be here this evening. It's going to be a fun webinar.
No doubt. And Kim is in her 26th year of teaching high school math and is passionate about using technology as a tool to explore and understand math. Kim is currently teaching geometry and BC calculus and has 5 years experience as an AP calculus reader. As a T-Cube instructor, Kim enjoys working with teachers, helping them to incorporate strategies for teaching with graphing technology. Kim, it's great to have you with us.
Pi Day is one of my favorites to celebrate, and it's so great to celebrate early with my math friends.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to Kim or Veronica using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, toggle the audio broadcast button at the bottom of your WebEx menu. At this point, Veronica is going to discuss the agenda.
All right. Well, Michael's doing the welcome and introductions right now, and we're also going to have Pi Day trivia through our webinar this evening, and that's something that we have it prepared in a TNS file that you could use. I know some people are getting back into school, or you can send them remotely, but you can still celebrate Pi Day either in the classroom or at home. We're going to do some collecting of circle data, and we have an at-home activity that, of course, can be used at school and a virtual activity. And then we have lots of fun team builder ideas and activities, things you can do in the classroom or with math clubs. An application of Pi, and that one's really a nice project for upper level math students to do. And then at the very end, we're going to show you a high Pi celebration that I always do with my students and any of my math colleagues. And if you've ever seen me around, I'll teach you how to high Pi.
Thanks, Veronica. I can't wait for that. And Kim is going to discuss our expected outcomes.
So by the end of this webinar, our goal is to make sure that each of our participants can enhance students' appreciation and knowledge of Pi, that everyone can use TI technology to organize and analyze some data, and be able to share ways to celebrate Pi Day with your students in person or virtually.
Awesome. With that being said, I think the best way to start this is with some trivia. So we're going to have a few questions for you tonight, and here's the first one, and let me launch the poll.
And I see the poll being there, so I'm going to go ahead and read it. And so, which famous scientist was born on Pi Day in 1879?
And if you're on a mobile device, your polling feature may not work. Just a heads up. I'll give you about 30 seconds to think about it. No cheating, Googling. Let's just get honest
No time for
answers.
Googling. That's
No
right.
time
No
for Googling.
Googling.
All right.
Let's see those results.
All right. Give me about 15 seconds.
And no sharing answers in the chat either. We don't have
You
the
guys are
feature
tough.
where you can just share.
All right, here we go.
All right, it looks like the majority of the answers are for Einstein, but I also see a lot of no answers. So if you're able to answer and participate, that would be awesome. But I understand Michael said that if you're on a mobile device, that's not possible. But all right, that's our first one. And so we're going to continue with some more Pi Day trivia throughout our presentation. So we're going to get ready to collect some data. And I know from friends and colleagues that we're getting ready to, some students are starting to get back into classroom, and just depends on their area, but some students are still at home learning. And so if you want to do some data collection, one thing is that students can go look for things around in their home. And so I'll show you a picture of what it looks like of some round things that I found at my house. And
We don't see the pictures yet. There it is. Now it's coming.
There it is. I lost my world there. Okay. Before though, I show you some pictures of round things. What I'd like to do is use your chat window. And do you celebrate Pi Day with your students? Is this something that you've done before?
I'm seeing some yeses. I'm seeing some every years.
All right. Sometimes this depends. Sometimes our Pi Day does fall on our spring break. And so if you haven't celebrated Pi Day, maybe this year would be something to consider. All right. So this is what I found around my house. You want to have some string, and you want to have a measuring tool. And this measuring tape has centimeters or millimeters on the reverse side. And so I just found some simple things that are round. I also, at the end of the session, have this document that you can integrate into Google Docs. It's Word. You can change it however you would like. That's one thing I love is during these webinars and anything from the education.ti.com website, we can always go and edit it to make it our own. And I'm happy to share that with you. So I'm going to enter in my data onto a TI 84 plus CE. And I need to go get a list. So I'm going to come here to my statistics, and I'd like to edit. So that's number one. And I'm going to enter in the information that I collected for my at-home things. And so I don't need to show you how I did that, but using the string and putting it around and measuring it. And that's something that students can do at home. They could even use a shoelace.
So what was your first measurement?
So my first measurement is the soup can.
Okay. And then what's going to go in our list one, I should say?
And so this is going to be circumference.
Gotcha.
So this is all the rounds. Thanks, Kim. And I'm just going to go down in a column. One thing that's nice with the TI-84 emulators, I can use my keypad to enter in information. Whoops, and I'm not pushing my 2 apparently. And 24.1. All right, so I have 6 items there. And now I'm going to enter in the diameter, 6.9, 5.8, and 10.2, 4, and let's see, I think I'm missing something. 21.7, 18.3, 12.6, 24. Yep, I'm missing one more right here. Let me put this one in. 12.64, 4.47. Okay. And then I do have one more. One thing that is important is that if you don't have the same amount of information in each of your lists, you'll get a dimension mismatch, and you're not going to be able to do any calculations at all. Okay, so I have the circumference around for list 1, and I have the diameter in list 2. Now, if you want to check to see how well you measured, or you can skip to doing a scatter plot right away, but just because I want to show the capability of the TI-84CE, I would like to move over to the top of list.
Before you do
The
that real
top
quick,
of, yep, yes.
we have a bunch of people that are
Oh,
making note of reasonableness of answers. And they
I
are
see that
questioning
right
how your
there.
diameter can be greater than your circumference, which
That's right.
I
That's right.
really
Thank
would
you.
like my students to do that, and to phrase it in such a way. So I think that's a great attention to
Thank you.
precision there.
Thank you, everybody, for flagging that for me. Uh, and I'm going to now go over to show some functionality. Up at the top, if you can be at the very top cell, and at the bottom you can see that it says list 3 is equal to something. Well, I have circumference in list 1, and I have diameter in list 2. And we know that this whole activity is to find the relationship between the circumference and the diameter. And so over on the keypad, you can see that I have list 1 over here. It's in blue. And so I'm going to go second 1, and I have list 1, and I'd like to divide that with list 2. And so second number 2 gives me list 2, and I push enter, and voila. And so this may be something you want to do with your students at this point, or not. It is an at-home or in the classroom manual collecting information, and so I have to say those aren't too bad for using a piece of string and a tape measure. And so now let's go and plot this data. So I'd like to go over to scatter plot, my stat plot. It's up in blue, so I'm going to go second y equals. And so now I have all the plots are off. And so I want to go, and I'm going to just stay with plot number 1. And I want to make sure to turn it on. It's flashing on, but you can see that the box is solid on off. And so to make that stick, I'm going to push enter. And now I have turned on plot 1, and you can see that this box is solid above it as well. I am wanting to have a scatter plot. And so now this is something to think about. What is in my list 1? That is my circumference. So I want to have my diameter as my independent variable. And so I need to change this to list 2. And now I have my dependent variable, or my circumference. I would like to change that to list 1. I have my mark. I'm going to leave it as that bigger square, and I like the color blue. So now I'm going to go, and I'm just going to go graph it. Well, there's my information. One thing I didn't do is I didn't reset it. So I do want to do something that might be how a student's calculator be at the beginning, and I'm going to go to Zoom Standard. And that's probably where the calculator would be. And so it's important to think about, well, why don't I see any of my information? And so I want students to think about, well, what is the size of the piece of paper that they should have? What is the size of the graphing area that they should have? And so you can go into Window and you can go adjust these things, or you can talk about that you're using some statistics right now, and you can see here for number 9 that you have Zoom Stat. And you can arrow down, or you can just push the number 9 and it gives it to you. And you can see that that looks pretty good. Looking at it, it looks linear. And then we can go verify that. So we're going to go stat, calc, and we know that we're thinking it looks linear. And so I can arrow down, or I can just push number 4 and enter. And so now what is in the X list? Well, is that list 1? Is that our circumference? No. So I need to go and say our X list is list 2. and our Y list is list 1. Frequency, we don't have frequency information this time. I would like to store this equation. And so what I want to do is in the updated version, we do have some soft keys up here with F1, F2, F3, F4. I call it a script menu kind of. And so if I go alpha trace, I can get to all my Y equals. I can get to my Y vars. Now, if for some reason you forget that that's the case, you can use the arrow keys to find out what is it that you want? What template are you looking for? So there's your fractions, there's your functions, and there's my Y vars. I'm going to go ahead and it into Y1. So I'm going to push number 1, and then now I'm going to tell it to calculate that regression. And so I'm going to push enter, and voila. And so you can see that my slope is pretty close to 3.14. And then I do have correlation coefficient information on. And I'd like to show you how you could turn that off if you want to. You go
Before
to
you do
mode.
that,
Oh, okay.
well, you can do it right now. So I love the emulator that you're using right now. And the emulator doesn't keep up live. Can you hit the little tiny refresh button on your
Oh,
right
absolutely. I
side?
apologize. Yep.
No, that's quite all right. And then there's a couple things that are going on in the chat that I think we should probably clear up a little bit.
Okay. All right.
On your graph, you had L2 as your diameter length. And so you
Yes,
didn't put your input in L1, you put your input in L2. And so this is
that's
one of those
correct.
cases where we want to make sure that we understand that the input, the horizontal, is the diameter, the way we inputted this in, because there are
Correct.
some questions about that. And
Okay.
thank you.
Yeah. So
And
here's the
then
list.
I will let you get back to finding the I
Yes.
value.
So on the way that I collected the information, and that's on the handout that I gave you, I have the first column as circumference. And so I have that listed in list 1. And then in list 2, that's where I have the diameter. And that was the way that I set it up. I do want my students thinking about what is the dependent and independent variable, especially in a middle school or freshman algebra class. For list 3, we did a calculation based on list 1 and list 2, which we know the relationship is circumference divided by diameter. So circumference was in list 1 divided by diameter, which is in list 2. So when I went though to go and graph them in my scatter plot, I know that the independent variable is the diameter, and that is in list 2. And then my dependent variable is the circumference, which I put in list 1. Hopefully that's cleared up all the information. Okay. All right, so let's go to mode. I'm going to quit out of here and I'm going to go to mode, and I can go down and I can turn off the diagnostics. So I can turn those off. Stat wizards make it really nice for me so that it does ask, and I do leave those on. I do prefer that. So I'm going to get out of here, and then we can go back and we can do the linear regression. And so I want to go calculate the linear regression number 4. And I have it already in list 1, list 2, no frequency list, or excuse me, list 2, then list 1. I want to store the equation. I'll store it. I'll practice those soft keys again. I'll store this in an equation or Y2 this time. And then I have to go down and tell the calculator to calculate. And so now I don't have those versions on there. So sometimes it's up to you if you want them on or not, or you can discuss them. And then I can go to my Y equals. I can go take a look. My equations, I pasted them in. And then finally, I can go look at my graph to go see how well does that match. And I have to say that looks pretty darn good for collecting information at home. Kim, is there any other Questions in the chat?
No, I think we got it. Just as a reminder, and it is mentioned in the chat, at the end of the webinar, there'll be a link where we have lots of resources for you. But I believe it's time for another trivia question.
It's time for another trivia question.
It
Yes,
is time for another
it
trivia question. So let's see which question is popping up now.
I'm ready. I just need control.
There you go. I'm moving that
Thanks.
world.
All right. The poll is open. So for mostly everyone should be able to just click on either A, B, C, or D. For me, the poll showed up on the right-hand side of my screen.
And so I know in my class, I like to do a set of trivia questions to like jumpstart the class on Pi Day or Pi Day Eve or wherever it happens to be. And sometimes I've also given them as assignment the night before, but Google's too much of my students' friends, so I like it to be quick enough.
One year, our math club did it for the whole school. And so the math club students had all the trivia questions. And then anyone who had the answers correct all went into a drawing for a pie, an actual pie to eat.
And the results are in. Michael, do you want to reveal the answer?
Yeah, I think I did. We got.
Oh, no, I was thinking with the Nspire document on the teacher emulator, where we just kind of flip it over as long as you're in the question spot, because it looks like that we had 30% C's and 30% D's. So what does the symbol represent? And a letter from Latin alphabet, pi as in P-I-E, a letter from the Greek alphabet, and then pi as in P-I. So this was a trick question because it represents pi. It happens to be a Greek letter.
Tricky, tricky.
Very tricky.
See, I thought this was an easy question, too. You guys are getting me tonight.
We tried.
And then Kim, I'm giving you control, correct?
Absolutely, yes.
Okay. It's all yours.
All right. So I'm going to be sharing my screen and talking about a bunch of different things. So one of our objectives was that we wanted to make sure that we provided you with some opportunities to do things virtually. And so I teach in a Google district, and so I created a Jamboard. I created a Jamboard for you, and I created a Jamboard for my students. So I'm anxiously waiting to when I can do this with my geometry students. And so what I just put into the chat is a link to this Jamboard, but you're going to make a copy of it. And then there's another file inside of our documents to share that has the link again so that you can keep on making copies of this Jamboard. And so what the directions are going to be in simplest terms, and of course you can change these for your own students, is you're going to drag and duplicate the M&Ms to measure the radius, diameter, circumference, area of your assigned circle, and you're measuring a number of M&Ms. So I'm not using a ruler this time, I'm not using a tape measure, I'm using M&Ms as my count. And I would like you to share your data with the class. And so I'm just going to show you what this is. I have done all these today. And this is my answer key. Sorry, let me go back to the other one. So there's this big circle, and we're going to drag these M&Ms over to determine the radius. And so kinesthetically, I would love to have M&Ms in my classroom. I would love to have students physically in my classroom. I'm teaching virtually right now, so I need something to where I can't guarantee that my students have M&Ms. I don't even know if they like M&Ms, but M&Ms are nice candies to use for this, and you can swap it out with any other one. And so I've determined that this has a radius of 7 by dragging those in there. And then my intention is that students would change that. And I would have a couple students working on the same Jamboard. So we have a larger circle here, a smaller circle, and you can kind of see how these get smaller and smaller. So I don't know that I would necessarily clue my students in on how these are designed, but it might be that I'm just going to give the one board to each one. So if you've worked with Jamboards, you can kind of start thinking about how you might use this with your students. I went through and did the activity and came up with some things that I would talk with my students. We might need to agree on how M&Ms should be placed. Do they have to touch? Would they really touch if I had physical M&Ms? Do they have to touch if they're these virtual ones? Where are we going to put them for the circumference? How are we going to deal with area? Once we've done this, do we have overestimates, underestimates? Is this an estimate or is this exact? You know, those different type of questions and answers. And, you know, how does this change if I actually measured something physically? So I did go through and the big circle is a radius of 7. So you had a diameter of 14. And then I did the circumference and I also had the area. So again, you're also going to get this one here. So my area is 154. So some people in the chat for the previous activities like, oh, I did this in my class and it didn't go well because we didn't get good measurements. Are we always going to get good measurements? If we're measuring, you know, that's a question to talk with our students and how can we get better measurements? So one thing I'm thinking of with the 7, I will tell you it takes a lot of time to fill it for the area. But it might be that 3 groups get the 7 and you take an average of their area counts because they're going to put those in differently. So just kind of thinking how we would build this in our science classes as well as our math classes. And so this is the 6 radius. And I had to do that one twice too because it's big. And the 5 radius. And we had the 4 radius, the 3, the 2, the 1. So as they get smaller, they're much, much more manageable to deal with. What I do want to point out is the extension. Again, I'm a geometry teacher, so, you know, my students might have done this before with other things, but if I kind of start leading them through, let's go ahead and focus on colors. If the radius was yellow, now I can put a radius of blue and a radius of red and a radius of green. And now I'm kind of developing that idea of what the radian is, which is something that I get to teach my geometry students this year. So when I was purposely picking colors as I was doing this activity, that was something that really kind of stuck out as something that I could connect in my class to the past or moving on into the future. So the other thing you might want to know at the Jamboard, once you put these in here, you can just click these 3 little dots and you can duplicate it. And I will tell you that's actually how I filled most of these. I didn't drag them, I actually duplicated them. So that will make it go faster when you're putting some things in. So that's the foundation for my students. I want to collect data from my students. I don't want to give them all the data. I'd like them to give me some data. So what we're going to do is we're going to put them in a lesson spreadsheet, just like we did with the TI-84. So here's my Inspired, and I'm using a CAS. This is not necessarily a CAS activity for this one. And what I'm going to do is I'm going to press menu, and we're going to go to list and spreadsheets, just like what Veronica did with our TI-84. And
Now, Kim,
we collected a bunch of data.
Did read in some of the chat window that I should have renamed my lists, and we were trying to save some time, but in the Inspire, it's much easier to do. And I know you're going to know that right now.
Yes, and we were kind of purposeful in that because sometimes kids can handle that skill and sometimes they can't. You know, that is really a debate here. So in the Inspire, what's nice is I just type it up here. And now I'm using my keyboard, so I'm going to actually write out the whole thing. So I took measurements of my radius, my diameters, and I had a circumference, and hopefully I'm spelling all these right, and I had an area, and I counted those with M&Ms.
They look
And
good to me.
so my radius, I had a 7, 6, 5, 4, 3, 3, 2, 1. And that was my radius. My diameter, we had a 14, a 12, a 10, an 8, a 6, a 4, and a 2. And I could see where some students might debate that and go, you know, that M&M kind of went over. Should I really count it as a whole M&M or not a whole M&M? So there's lots of good conversations with that. My circumference measurements were 44, 37, 31, 25, 17, 12, and 6. And my area measurements were 154, 103, 76, 48, 26, 12, and 3. And so
And
I
Kim,
have all
again,
my
using
data
the
here.
emulator, you're using your number pad on your computer keyboard.
I am using my number pad on my keyboard right now, yes, for ease of use.
So it just makes it
And
easier.
if students have a computer, when they purchase a TI-Nspire, they also get student software, so they can do that as well and use their keyboard. So that's something that some of my students have done who have computers, not Chromebooks. So we would like to do the same thing. And so I would like to go ahead and add a page. So on my Nspire, I'm going to hit Control Page, and I would like to do some data and statistics with this. What I love about my Nspire is just the ease of switching some of these things. So I can compare the radius to the circumference. Hopefully that is a linear relationship where the circumference is just doubled the radius. I could switch this right off the bat. I'm sorry, I was talking about the diameter. I could switch this right off the bat to think about the diameter there. I could switch it to radius. When I did that, it was radius and diameter. So I would let this be a radius right here. Or actually, I'm going to do diameter to circumference. I could also look at radius to area. And I can see where I
Notice how
have
on
a
the
lot.
TI and
Yeah.
nice curve. I was going to say, notice on the TI-Nspire there how it's so easy to change those independent and dependent variables by just clicking over in the horizontal or vertical area with the name.
Yeah, and one thing I do like to do is I can add a variable here. And so say I want to see circumference with my radius at the same time, which is a different relationship than looking at the circumference and the diameter, but I do kind of see that line there, which is kind of cool. When I work with people and when I do this with students, anytime I get out a list in spreadsheets, the first thing that students ask me is, what's that second line there for? And so what I'm going to do right now is I'm going to dock, insert a problem. So this problem is not connected to the other one. And I'm going to do the same thing. I'm going to talk about my radius. I'm going to talk about my diameter. I'm going to talk about my circumference. I'm going to talk about my area. And I'm going to do my inputs because I designed this to be a 7, 6, 5, 4, 3, 2, 1 data input. But now that second line is how Excel works. This is where I'm going to put in the formulas. And so my diameter is what? Twice the radius. And so now I'm looking at the exact answers. I'm looking at the mathematical punchline. So I'm just going to say 2 times A, and it will populate that. So that second line with that equal sign is my formula bar. And so a lot of times we'll say, oh, don't touch that. Or just skip over it. But now is a really important time to kind of think about this. Now, my circumference, if we know the answer, it would be pi times d. So I can actually do pi. And when I type, I usually just type in pi, but I'm going to use the pi button. So I'm going to do pi. And I'm going to do times, and my diameter is in row B. So I'm just going to hit row B there. And because I'm in a CAS calculator, I'm getting an exact answer, which is 14 pi, which really doesn't help me with my M&Ms. So I'm going to go back up in here and I'm going to click in and click in front. And my fastest trick for working with spreadsheets is to do 1.0 times pi times b. And I don't need the 0.0, but it usually helps students so that they realize that they're putting a decimal in there. And it's going to say it's going to overwrite the data. Great. And there's some information, which is kind of cool. And then I'm going to do the same thing for area. So for area, I'm going to do 1.0 times, and so it was pi, so I'm going to do pi times my r squared. So where is my radius? My radius was in a, so I'm going to do a to the second power, and there's my formula. So, and
Voila.
I know that I've gone really quick with this here, and just looking at some data here. I hit the wrong button here. So this was my count of data. And here is my calculation of data. So I don't know if you can see this too much on the side over here. It's kind of hard to, sometimes I can force two screens at once without sharing it. There we go. So I want this one and that one. So my area calculations 153.9. I counted 154. For 6, it was 113. I got to 103. This is a calculation of 78. I got 76 M&Ms in there. This one's supposed to be 50.2. I got 48. So, and honestly, I kind of looked at the answers and tried to make them look a little bit better, but it was hard to fill in those M&Ms and count that. And I think that's important to have real data. What's beautiful about working with this one, so I'll work with the real data on this one, is I'm just going to hit control page again. And so I'm going to go to that data and statistics. And so now I can go ahead and look at, I'm going to look at radius to area. I'm going to see that beautiful curve there. And so when I hit menu, I can analyze my data. And so I'm going to look at that quadratic function. So I'm going to show that quadratic regression. And, you know, it's supposed to be exact data. So I do have my pi x squared where my input was my radius. So that is my r squared, which is kind of cool. And we were seeing people talk about, okay, so what happens over here? So I'm going to do the same one. So I want to keep my area. I'm hitting right click is what I'm doing, is to get rid of that on that side. And so I have R and area here. So I'm going to do the same thing. I'm going to do menu. I'm going to analyze, and this was my M&M data. Do my regression. And so for this quadratic, I got 3.416. And, you know, on a multiple choice test, like the ACT, we can tell students estimate pi as 3 and see which choices will work. That's pretty good for the type of data that we collected. So I'm not disappointed with that, but I do want to make sure I have that conversation with students. Why isn't it exact? And some other things there.
Kim,
Any
that
questions in the chat?
you mentioned when you were using your computer keyboard that you did a right click to force a second variable when you were displaying two, but on the handheld, you can do that by going control menu. That's your right click
Yes.
functionality when you're using your TI-Nspire. So you still have that right click capability, and it's a control menu. And again, that's
So
kind of the secret menu thing I teach my students.
So if I'm over here, I'm hitting control menu, and then it gives me those extra options. And that's what that little box up above is giving them. All right, is it time for another question?
It is time for trivia.
It is time for trivia. All right, so this is the third one. So I don't know if anyone has a perfect score yet. Because that last one was tricky.
I'm not keeping track. I know I don't.
Well, I'm just thinking personally, if you were to keep track like a bingo card, how many points do we have each? I do like doing this throughout. I think I might do this in my class instead of giving them the whole quiz this time.
Yeah.
So we have the who completed the first proof to find the number pi. And this right here, I might give bonus points for people who can pronounce these names correctly. Do you want to try, Michael?
Definitely.
I believe the first one's Socrates, Pythagoras, Boyle, and Archimedes.
You would get a high pi button.
But I'm not
You
sure
would get
my
a high
students
five.
could do that correctly.
I don't think my students could do that. Well, and unfortunately, with some popular movies out there, I admit I see Socrates the first time I look at that, even though I know it's Socrates. And I would never accept a mispronunciation if I had the opportunity to fix it.
Right. Let's see the
Yeah, I was wondering,
answer.
is Pythagoras spelled correctly?
Pythagor. I think so.
Is there?
I'm not good with
Okay.
typing. I admit I typed that one, so.
I think we might be missing an O, but I'll double check that.
Okay, thank you.
Not with advanced auto parts.
No.
You never know.
It's true. They probably do need some Pythagoras in their life. All right, so the polls have been shared. And Veronica, am I giving the ball back to you?
Yes, sir. Oh, there's my polling. I couldn't see my polling. How was Kim?
We have most people getting it correct with D being whatever the choice was for D. I forgot what the question is
All
because
right.
I'm trying to spell Pythagoras and see if I have it spelled wrong on there, which I think I do.
All right.
Pythagoras.
Pythagoras. Okay. Piece of pie. One thing that I like is to try to incorporate all of my students and in math. There's not always a lot of, I'll say, artwork opportunities. And so I'd like my students to all be a piece of pie. And here is a display that I had in my classroom where the three, it doesn't look like it, but it's a bigger paper plate. And then the other numbers are like an inexpensive plate that I distribute and give to students so that they can then decorate their own piece of pie. And so I have a little sign up sheet, and sometimes students have their favorite number. And so they pick the number that they would desire, and I give them a few days to decorate. So here you can see the 3 is much larger, and I have my point, and then we go, and I'd like to have at least 100 digits of pi, and if not more. And this continues all around the perimeter of my classroom. And I tape them up, and usually they stay till the end of the year. And we do that at preparation for our Pi Day
And
celebration.
can you remind me what size plates those are? Like, I think they're the little
So
dessert ones.
yeah, so the first one, I have an example of one that a student made, put in my front of my face. So here he made a pie, and so it's with those, and it's a larger paper plate. So I always, for a student volunteer or a student that I know is in an art class, or really because I want that 3 to be razzle dazzle, and on a larger plate. But the other plates are just inexpensive. I get mine at Walgreens, and they're just little dessert plates, and they're very thin. I really like to keep a little bit of the concaveness. So I asked them to not, jam it into their backpack, but and you can see most of them did pretty good. So that's just how you can incorporate. And at any level, kids can decorate and create a number to put up to be a piece of pie. Another idea to think about is there's a lot of pie cookie cutters. You can buy them from lots of retailers. Kim and I have backgrounds, and so I have my pie or my piece of pie cookie cutter, and that's always fun. I know now with COVID, everything's a game changer, and it used to be that we had food in the classroom, but you could still enjoy them and have virtual Pi Day cookies with your family. You can always have a Pi Day bee, and participants. So not only your students, but maybe other faculty members want to demonstrate how many digits of pi they have memorized. A past student of mine memorized 100 digits of pi, and last year in celebration of Pi Day, she still had them memorized, and she sent me a little video clip on Facebook. And so that was really kind of fun. And that sticker that you see there, Kim designed that. And so this next one is that you can make Pi Day stickers or buttons that you could share with your students. And we're fortunate in our district that they have a print shop. We have a print shop that can be utilized. And this is just on name tag paper. And they printed those up and cut them for Kim so she can give them to her students during the week they return next week.
Yes, and
Something else you
we
can
put
do,
those in their interactive notebooks. So
love
I know
interactive notebooks.
some people are always worried about stickers and where they land at different places, and so we have a math notebooks in our classroom, so that goes in our math notebooks.
So always pie food, that's always fun. And I just thought that was a really clever pie crust there. But again, probably going to be very different with COVID. But we used to be able to bring in round things to share and snack on. I always brought in fruit pies for students, but at home they can still take a picture of something round, a round piece, round food item, a round object, and that leads us to a scavenger hunt. At our school, we're also fortunate that we have an Ellison machine, and I purchased a pie symbol. And so you could get there or have a teacher's assistant. You could put pie symbols throughout the school or the campus or even in your classroom. You can use those and have pie messages and put them in teachers' boxes. You could do a scavenger hunt at home where kids are looking for items that begin with the PI for pie, or you could have them find round items and they could take pictures of them or show them through their webcam. So you can try to do different things with a scavenger hunt. And then this is also going to be shared with you, but I created an exit ticket. Oftentimes, it's nice to kind of get I'll say a pulse or a beat as to, how did students do today? How did I do today? Really, that's what I think about. And I want to see how well students are understanding this new concept. And so you can make these. I have them 2 on an 8.5 by 11, but you can print them and have 4. And you can propose a problem, a question, or students can ask you a problem. There's many different ways that you can use an exit ticket. So I'd like you to use your chat. Does anyone have any suggestions as to or things that you've done to celebrate Pi Day? And so I'm going to stop sharing, and I'm going to pass the ball over. Michael, are we going to do one more trivia question?
Yes, it's time for another trivia question. While you were chatting, a lot of things were shared in the chat, and some things
Okay.
were different books, like Circumference and the Knights of the Round Table, different things that you can eat. What I love about your exit ticket is the fact that some people take Pi Day as a school-wide celebration. So your English teacher could be using that exit ticket while the math teacher is dealing with measurements and doing math and stuff like that. So that's one way to include everybody without including the food, but the food is always fun.
Several years ago, we had a full school Pi Day celebration, and the administration purchased pizza pies for the whole school. Everyone was able to get 2 slices of pizza pie, and Fry's donated some cookies, or a Kroger. Is our equivalent. They donated some round cookies. So that was the ultimate, and it was on a Friday before spring break. So it was fantastic. So our results, I think, are coming up for our
Yep, 5
Pi Day
seconds.
trivia. And so after this, now Kim's going to really demonstrate. It's going to be, if we had you on audio, we would hear a lot of wows, a lot of oohs and ahs. This next thing is awesome, and it's a neat thing that you can also just show and demonstrate to your students as well.
Sorry. There we go.
And so there we have our results. We're getting a lot of participation. And there we go. We all know it is irrational. So that's awesome. Again, we're going to share this in a TNS file that you can share with your students. And if you have a Navigator system, you can always send these questions out. Some participants didn't know that your TI Nspire CX Premium software, you have the capability to create questions and with responses and to get input from your students. So I saw that as a good suggestion for another webinar another day.
Absolutely.
All right, Kim.
All right, so this is kind of like a show and tell at this point, so we're not going to get to do this. You can look at the donut on there. And so I had to find something to do with my calculus students for Pi Day that was worthy of calculus. And so a friend of mine, Sharon Bruce from Colorado, she's another TI instructor, said, go ahead and find the volume of a torus. And I'm like, a torus? What's a torus? And a torus is pretty much a donut. And so this is something that I do in my calculus class at what I'm going to show you at kind of the complexity, but I also do this with my geometry kids. And so I teach geometry and calculus, and my geometry are normal children, and my calculus students are calculus students. So I have the spectrum in my classroom, and there's just some things that I change with it so that everybody gets to experience donuts around Pi Day. And so we're going to talk about the volume of a donut. And so a donut is a torus, and it's a donut-shaped solid that is generated by rotating a circle of radius r centered at capital R, comma 0. So if we're thinking about in my geometry class, I'm looking at this circle. Where did the circle come from? It came from a cross section. Definitely geometry content, right? In calculus, we've done areas and volumes, or we're doing areas and volumes depending on where things are following, but we've pretty much done areas and volumes. And so the one thing that I love to show my students on my TI-Nspire is the fact that we can graph in 3 dimensions. And so this file I give to them like this, and here's a torus for us to rotate around automatically and look at some things. So my Nspire, if I hit my A, it'll auto rotate. I can hit my X, I can hit my Y, I can hit my Z, I can go back to the origin, and I can rotate this around, which is pretty cool. The fact that I can animate something on my TI-Nspire is really cool. And so that particular torus was built using parametrics. I'm not teaching my students that. I just have to be able to answer the question. And if they're interested in that with it later, what a great jumping point to get into some other mathematics. And so we're really talking about how are we going to build this? So in your list of resources and all their resources, there's a step-by-step, this is how I would problem solve it. My goal with my students is for them to problem solve it and not to follow the recipe to get to the answer, but what is provided is the recipe to get to the answer. And for my geometry kids, it's like, okay, so I have this donut. We talked about this cross section. Here's my cross section. What do I have to do to get a donut? And that's not how the donut is actually made, but the fact that that cross section is going to stack up to get a volume and stack up and curve. So now we're kind of getting to Cavalari's principle. So I can move that back into as review, or actually kind of pre-teach it, depending on where I'm at my curriculum. But what's nice about the sliders, if I grab the slider, now I'm doing that revolution about the axis to get that solid. And my calculus kids have done volume, and they've seen me do this, but when they get this in their hands, they're like, oh, that's super, super cool. And maybe it's super cool because they have donuts in front of them. And so when we're doing this in class, this works best with the glazed donuts. You kind of want to get it as circular as possible and then realize that it's fake as possible. I've done the cake donuts. Those work too. And what I did with students, and it was last year, it was the last activity I did with my kids. We had cake donuts to eat, and we measured the glazed donuts. And I've done it different ways. And sometimes I just have the assortment of donuts in the back of the room with them. The other thing that kind of helps is to use those paper rulers. They can just throw them away when they're done. They can cut them apart. They can shove it into the dough, whatever they want to do with that. And so I did give them the directions, the recipe, because this is on assembly day. So it's not like I have a full class period. So if you want them to do the whole thing, it does get to be a little intense, but just even recognizing and having the conversation of taking that circle and rotating it. And then we can see how we're measuring some of those other pieces. So this particular answer key, this file is built up using millimeters as my measurement. And so what is happening is I give the kids at least the diagram that says how we want to measure, what our radius is going to be. We have the radius of the cross section, we have the radius of the torus, we have a bunch of different things. And so they measure those and put them in to the table using this legend, I should say. And I asked them to find the area of the cross section using geometry. So my geometry kids can definitely do that. And then we talk about the formula for a circle, that equation there. I do have my calculus students solve for, what value did I have them solve? I've had it in terms of X, so they did have to do some things. And then this file, I do want to be clear, is a CAS calculator. So we can do everything algebraically in there. But I want my students to do the left side and the right side of that circle so that we can do the calculus of finding that area using the integral. And we want them to get that answer and compare it. So I do have my calculus students set up the integral, pretty much doing that right minus left, knowing our starts and stops, and then to compare it to their geometry answer. And a lot of my students are always like, oh yeah, I forgot that we could do geometry. Of course you can do geometry. And then we do the revolution and the volume using the formula. And then that gets us to that volume of a torus. So the volume of a torus is 2 pi times the radius of the torus times the area of the cross section. So when we found that area of the cross section, we can use it later. When we find the radius of the torus is really looking at the center of the cross section to the center of the space of what I'm going to say the donut. And so again, I can have my geometry kids do that. We input into formulas a lot in geometry. So it's not necessarily about giving the whole activity, but connecting pieces of the activity to things. And
now,
that
Kim,
means,
you're going to share this TNS file with our participants,
yes,
or it'll be
our
in the documents
participants
folder.
get the
Okay.
answer file, and then they also get the student version that doesn't have the answers in there, other than this first page and the second page. But this part right here, they would have to enter in their own answers, which is what my students were doing to
All right,
get those other
Michael, we're going to have to
calculations.
skip that last Pi Day trivia question, and
are.
we only have a few minutes left, and I really would like to show everybody how to do a celebration high pi. So Kim, if you want to just pass me, there we go.
Yep.
I'm going to go ahead and share my screen. She is super fast. And I'm going to go back over here. And so when Kim and I were planning our webinar today, our Mathtastic Pi Day webinar, we wanted to end with a high pi. And you know that everybody always does a high five. All right, high five is very common, but we're going to high pi. So you need to have your hand, and you can do this with your students, and you can even do it virtually. And so here's how we do a high pi. So it's 3. So we're using the decimal approximation. So 3 point pound 3.1 and then 4, and you want to be cool about it, and you can twiddle or shake or move those fingers around. And so I made a gift for you that you all have, and here it is, 3.14. And so We do that as celebration in my classroom, and we start that early on at the beginning of the year. And so we always are high-pieing each other, and I encourage my students to high-pie each other. So if you want to have that GIF, it'll be available in all the documents. And I want to thank you. Oh, I want to show you my shirt. I have all kinds of high-pie buttons that I make and hand out to participants at the conference. This gift too that I made will also be available to you. And I need to stop sharing and hand this back to Michael. So thank you, everybody.
Thanks so much, Veronica and Kim. To get a copy of the certificate, go ahead and copy that link in the chat window. And also this link for the documents which were used tonight. We do need to add a couple more documents to that link, so feel free to check out that link tonight, but don't be afraid in a couple of days to look in your email. You'll automatically get a follow-up email for this webinar, and that will contain a link to the certificate, the documents that will be updated, and also a link to the recording. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. So a big thanks to Veronica and Kim. It's 9 o'clock where I'm at on the East Coast, and I'm probably going to have to go through my pantry and try and find something to eat because now I'm hungry. So thanks so much for that. Thanks to everything you put together. And thanks to everyone for joining us tonight. We hope you have a great Pi Day, and hope to see you back online real soon. Have a great night, everyone. Stay safe.
Bye, everybody.
Bye.